Which of the following statement is not applicable to H2SO4? Option A, the molecules are associated by hydrogen bonds. Yes, H2SO4 molecules are associated by hydrogen bonds. Okay, you can see here H2SO4. One more molecule if you consider H2SO4. These molecules are held together by intermolecular hydrogen bonding. This dotted line is a intermolecular hydrogen bonding. So option A is correct. H2SO4 molecules are held together by intermolecular hydrogen bonding. Okay. Next, option B, oxidation state of the sulfur is +6. In H2SO4, sulfur oxidation state is +6. If we calculate the oxidation state of the sulfur in H2SO4, the oxidation state is +6. So option B is correct. Then hybrid state of sulfur and oxygen atoms of OH groups is same. If you consider the sulfur here, around sulfur total 6 bonds are there. Double bond is considered as a single bond pair. So total number of bond pairs of electrons are 4. 4 bond pairs of electrons around sulfur. 4 bond pairs of electrons means hybridization of the sulfur is sp3. And oxygen atoms of the OH group, if you see, oxygen total 6 electrons in the valence shell, 2 electrons are involved in the bond formation with 2 bonds, and here it contains 2 lone pair of electrons. Anyway, total number of pairs of electrons are 4. 4 pair of electrons means hybridization of the oxygen is also sp3 only. So option C is also correct. Option D, if we consider, the acid always exhibits basicity of 2. Here H2SO4, it can form 2 types of salts. For example, with NaOH, it can form NaHSO4 and also Na2SO4. So it can form 2 types of salts. Here it is basicity is 1. In Na2SO4, basicity is 2. So it is not always 2. It can exhibit one basicity 1 and also basicity 2. And one more important point I want to mention here. In aqueous solution, if we consider, in aqueous solution, H2SO4 ionizes in 2 steps. That is, H2SO4 aqueous gives rise to H plus aqueous plus HSO4 minus. Acid dissociation constant, that is Ka1, is 1 into 10 power 3, and HSO4 minus ionizes to form H plus SO4 minus 2. Here the acid dissociation constant Ka2 is equal to 1.2 into 10 power minus 2. If you see here, the acid dissociation constant Ka1 is greater than 10 and it is 1 into 10 power 3, means H2SO4 is largely dissociated into H plus and HSO4 minus, because greater the value of dissociation constant, stronger is the acid. So H2SO4 largely dissociated into H plus and HSO4 minus, but anyway it can form the 2 types of salts. For example, with NaOH, it can form NaHSO4 sodium bisulfate, and also with NaOH it can also form the Na2SO4. That means the 4th option is wrong here, because it can also exhibit the basicity 1 and also basicity 2. And one more important point is it largely dissociates into H plus and HSO4 minus. So for the given question, which of the following statement is not applicable for H2SO4 is option D.